Welcome student to this second practical of the DSBD analytics, where we are actually doing these operations. That is, we are doing the operations. Here we are using the code, say markdown. And our operations is here, that is DSBD group B, GB, that is group B, practical 2. We will go with an air for air quality for A, and similarly you can go for the I'm just making change DSBD GB to A. This is the name given to this. Typically is perform the following operations on air quality and hard data set. So we already had this thing. So first that we have to do the first operation is obviously data cleaning. Then we are going to do the data integration. So data cleaning is the first operation. Second operation that we have to perform is data integration. Then we have to do the next operation, that is data transformation. And last operation which they ask in the assignment is error correcting. So error correcting. These four operations we are going to perform on the two data sets, air quality and hard data sets. So as you already know, I'm just keeping this. The next is what we are going to write the code. So obviously the code is that we first require the standard libraries. So we are seeing Pandas as PD. We are importing Pandas as PD. Then we are importing NumPy, numerical Python as NP. Okay. So these are the two commands that we are giving here, and then we are giving one. Okay, I should say import. While talking is made importing. So next is that we have to create a data frame, and this data frame we are going to have pd dot read underscore csv, and we are having already this csv file with us. I'm just what we say so see, I'm just copying that path here, csv file, and saying control V, and how to change this path, single colon. Here this backslash need to be converted into forward slash, otherwise you will get an error. So we'll say this is the address where I actually saves my data sets, all data sets, and here I'm giving the CSV file name in single quote. My CSV file name, I am also copying that data set name actually. control V dot csv. So this is the file that we are actually reading pd.read and converting this into the data frame. Now here you can also add the encoding and everything. Let's see what this command gives us. Say df and we'll compile this. So for df we are not getting any output. So this happening because data may not be encoded properly. So we are going to use the encoding that is an internal parameter for this, and the encoding again single quotes we are doing CP1252 and here we go with the things. So we got some output. We say that users del column 0 have mix type is, and here we got the complete things. And now in see this is not a number nan. Okay, and here we are having this all nan and other thing. So whenever we are having this nan or something, we cut it down. Okay, from this thing, or we replace it with some value, we call it as a data cleaning. Let's see, we are going to see the some information, that is what are the head, that is the number of features or dimensions of this data. Let's run it. So that is a standard code, sampling date, state, location, agency, type, SO2, NO2. These are the head. Now we can have after this head, I'm just taking the information of the data frame generated. Now data frame generated is having this information that you can have. So if you go with an df.info, okay, it's going to it's actually going to show you the info. So let's run. Now what is the info? So here you will see that it shows that this is a class, that a data frame class is pandas.core.frame.dataframe. Then is having the range of the index, which actually starts from 43 actually 4,35,742 entries are there, and obviously so due to that your range of index actually lies between 0 to 4,35,741. Now for these data columns, if you go, there are total 13 columns, means this data set is having total 13 dimensions, okay, or 13 features, okay, or 13 columns, or what you can call 13 attributes. Okay, so these are the different things they are given, and these 13 they are given. You are in the STN code, sampling date and language, and one is the indexing, that is the 13th one. Okay, and data types for this as a float 64.5 and object 8. So memory usage is 43.2 plus megabytes for this thing. Now we are going to check these df columns. We are going to do the first operation on this, and that operation is data cleaning. Now to do this data cleaning operation, we will check that is first df, okay, and we will go with SO2. We are having this SO2 here. Yes, SO2 is there. We copy this SO2, Control C. Now why we selected SO2? So now if you check here you'll find this SO2, okay, that is 4.8, 3.6.2. These are the values given to this SO2 and likewise, and then we are having a nan there. Okay, so we we are just using that SO2 to save something data. So we are saying we are check what you can say, mm, shrinking it into something. So we'll say df. Once again we will go with things, and here we are copying paste, that is SO2, that is name, and we are changing its type as type. So the first type for this was float 64. So we'll make it as a float 32. Float 32. Okay. Now the next we are going to change the this df, and we are going to use here this date. Okay. Now why we are using this date here? Because if you see, the date is stored in a different way, so it requires more data to store the date. So we are just going to change this as type, obviously date as type, and instead of saving it as type date, we are going to save it now as type string. Okay. So it is saved as a type of string. Now what will be the output for this? Let's check. When we do these things, we must have to get something which should have to be appreciable. So we have to get the info. Let's run this. So we are executing this. Now if you see, so, class, pandas, everything is there. Where memory usage is 41.6 plus MB, and here the memory usage is 43.2 plus MB. So this is what we call as shrinking. That data is actually shrink. So if data is shrink, memory requirement is less, we can say it is a data optimization. So this is a one process of cleaning of the data. Now another cleaning of data is that is wherever the duplicates are there, okay, we have to drop them. So we say that is df equals to, that is from all this df dot drop duplicates underscore duplicates. This is a bt, that it is an inbuilt function of the, okay, and then we saying that is okay. We will go and see the df. So just a minute, we will see what will be the output. So duplicates are dropped, and now we got more clean data. Okay. Duplicates entries are dropped, and we got the more clean data. Now the, if you see this, it is having total 4,35,068 rows. That is what you can see the entries. Otherwise, if you go in and see the prior to this, this information, it is around 4,35,741. So when we drop the duplicates, okay, the total entries they are actually minimized to 4,35,068 only. Okay, so this is what we say. Now we are going to check, is there not a number? So we say that is df dot, okay, is a name or not a number. If it is true, then we are going to add actually the sum. This is a minimum something, what you can say, and so you can have the other thing. So we can say that is percentage missing, percent, what call this as a missing, sorry, underscore miss. Okay, we call this percentage miss equals to df dot, we are checking whether it is null. If it is null, okay, is na, is na, and is null are quite a similar function. They just checks for the whether there is something what we call as 100, and it's divided by length of data df. So if it is missing, I will check this 100 divided by length df and something. Okay, and this percent missing is there, so we'll go with a percent miss. Okay, we are going percent miss, and we are going to sort the values. We have done the sorting in first thing, so we are going to sort these values. Okay, and obviously we are saying ascending equals to false. So now this sorting that we are doing, we are saying ascending is far. Okay, and this is what we have done this. Now let's see how the df looks and run this. So we got this is man and everything. We can also if you want here, we can also see instead of df, because we have done all these operation, but all operations are done in the percentage means. So instead of saying this, let's say percent underscore means, and rerun the things. So here we got this percentage miss detail. So if you see, that is 464 and everything, STN code and all those things are there. Percentage is calculated percentage and likewise. So this is what data cleaning is. It not a data cleaning is going on here. Now we are going to drop the STN code and as well as the agency. So we are saying df equals to df dot drop, that whatever we want to drop, that is what we are saying, and we want to drop the two parts here. Okay. Comma, we are going to give and comma, and then we are going to give the axis that is on the same can say zone. We are going to delete this, so we say axis is equal to 1. Now we are going to first drop this STN code. Okay. Control C and putting here STN code, Control V. Then we also going to drop the agency. So you can drop in, you can even drop the location or something. So we are just dropping the random attributes here. So we are dropping two random attributes, STN code and agency, on axis equals to 1 for this df. Now we are going to what we can say, check the df head. Obviously, and df columns also, but first we are going to check the df head. Okay. So here if you see the df head, this STN code and agencies are dropped. Now we are going to see the df columns. So we go with columns, and we will compile this. When you run this, we get this index, sampling data, and every got this. Now we run this. Here we got all zeros. So things are done. Okay. Now so here is the simple thing that we have to write down the for loop, that is called for call in df dot columns. Then you have to go df call dot type and df call and the ADF is showing, and now we are going to see what is the data set, data frame output is there. So just ADF and we see the output. So output is here. Okay. Now after this we are going to start. So this is what we have done, is we have done the data cleaning. Now if you see this DF, here you are not seeing any nan value. Okay, for example here we are having these nan values, those are completely removed. So first part is completed. Now we are going to do the data integration. Okay, so external data integration. Data integration operations are is here. We already have seen this. So we call this as a, we create two subsets and we make what you can say, concat these subsets and likewise. So we'll just go with a we call subset 1 as a sub1. Sub1 we are giving df, and we are simply selecting very few of this state. So we'll call this as a state. Okay. Only two variables, so state, and here we are using the type. Okay, so the sub1 is having this. You can have this sub1 here. For data integration we are doing this. So sub1 is having only these two elements, state and type. In the same way we are going to create the sub2, that is subset 2, and in here in subset 2 we are having once again the state, and we also have the location. Okay, we are going to have the location. So if you go and see these, okay, let's say sub2, that is subset 2. So we got the two things, and here we have the state plus location. So here we are having state and type, state and the location. Now we are going to integrate this. So let's call this integral, or you can call this as a concatenation also. We are using integration. Let's call this as integrate df. Okay. That is equals to, that is we assign that variable and we call this pd dot concat, and in pd dot concat we are first this concatenating sub1 with sub2, and we are concatenating at a head wise on the rows. So head is called as axis equals to 1, that is the head row. So we do this, and we are doing now what we are going to display this integrate df. So when we run this, execute this, what we get here, the state, type, state and location. And now we already had this one thing. You can use this drop duplicate, and you can do this, or you can simply say this. Okay, so this is what we call as an integration. Now if you want to use the drop duplicates, just see here we use somewhere, okay, sort values and then yeah, I'm going to copy this, Control C, just to check what will be the output. Okay, it's not going to delete anything. So Control V, we'll say I'm just saying here integrate df integrate underscore df equals to integrate underscore df drop duplicates, and now we are going to see integrate df check. Okay, so obviously consider every feature as a different feature, but if you are having, it drops the duplicate entries for all this. So we got this. Now we are going to do the error correction. Next part is the error correction. Error correction. So for error correction, we are defining a function. Okay, we call this function as def rm outliers, rm underscore outliers. So outliers, that is we are adding here columns, colons, that you have to do, and then enter. We are giving q1 equals to column dot quantile, and we are adding 0.23%. Then we go with the q3 equal to column dot quantile, and we are giving 0.75%. Okay, so no, this must have to be 25%. We are going to do some IQR, that is differentiate here. Let's call this as IQR equals to, we call say q3 minus q1. Okay, and we calculate the threshold that is equals to, let's say 1.5 into IQR. So calculated this 1.5 into IQR. Now we call outlier mark. Okay, so we go and say outlier mask, and we create this outlier mask. Its column is less than q1 minus threshold. Okay, R, this is bitwise R, what we called something. So column is greater than q3 plus threshold. Okay, q3 plus threshold. This is our outlier mass. Okay, once this outlier mass is done, what we are doing, we are returning column. We return column. We have to add this tilde mask here, tilde mark, and then we call this outlier mask. This is what our function is done. So function is defined. If you see here, a function is defined. Let's run this. So column unmatch. Okay, here in condition you got this one condition, this is there. You have to meet this, or we can add extra here. So let's check. So error is not there. We just have to do this, and now once this is done, we simply have to check df.columns. Okay, df.columns that we are checking. Okay, df.columns that we already know. These are the different columns or the features or things we are having, and now we already know this column name. Okay, so we'll consider this column name as a underscore call name. So call name equals to, and we are adding to this call name the call names which are here. So we are just copying this call name. Easy. Control C, Control V, and we just added this. So here we got the column name. So once these column name are there, now we are going to write down a for loop. So for obviously call in call name. So we call this call in call name. Okay, and that's it. We have to go with a df, that is data frame. Again we have to call the column equals to, and you have to call the function. Our function is rm underscore outliers, and input to this is df.call. So input to this is df and call. So this is a thing we have given. Now this, once this is done, we just run it. Not call rm out LIERS, just say 32 df call columns, column. Okay. Just make this, yes, remove this. Now what it says, we still have that same thing. Now what it says, so it is extra s that we added here. Now this column is there. So now we just have to find out what's our df look like. So I'm just showing the data frame, and here you know this SO, NO, NO2 for those columns only, SO2, NO2 are assigned. All the outliers are removed. Okay, so this is what we call as an error correction. Now the last is what we call as a data transformation. Okay, So we'll go on doing the data transformation. Data transformation. Now for data transformation, we are going to import the scikit-learn library and for data transform. So you can say from scikit-learn or sklearn, sklearn dot pre-processing import label encoder, L capital E capital, label encoder. This is specially used for label encoding. Okay. Now you have to say that is call label equal to call LBL. I call this as call label. Okay, just call this call label, and this equals to. Now we are going to add state, location, and what is that again? Type. These are the encoders. So this we initiated. Now we will say that is en is equals to. We are going to initiate the label encoder. So call label encoder and initiate in. Okay, and now for go with these things for call in df.columns or call in df.columns. We go and we say that is df call for every column or every feature in this df. So is equals to, we are saying that is n, that is our things dot fit. Okay, transform and here we are saying df call. We say here df call let's check. Okay, and now see the df. We got the df also. This is the transform. So this is the second experiment of data science and big data analytics group B 2A. We have done this on air quality data set. Now instead of air quality data set, you can use the hard data CSV and you can repeat the same operations on the hard data set and you will get the things. Now just to check, you can say if you want to visualize certain data, you can visualize this using matplotlib and cbon and everything. We are going to see it in next program. Thank you very much for thank you very much for giving such attention to my program, this Python program, and don't forget to subscribe my YouTube channel TutorASRumale if you like it. Thank you.